Here's the solution for day 2, problem 1. Identify the slope and y-intercept for the graph of y equals 2/5 x subtract 2. This linear equation is in a form called slope y-intercept form. In this form, the coefficient of x is the slope. And so we can quickly get that the slope is 2/5. Also, when an equation is in this form, the constant term is the y-intercept. And so that's also very quick to figure out. The y-intercept is -2. And with these two values, we can graph the line for this equation. Start with the y-intercept. On the y-axis at -2, there's a dot. So here, where the axis cross is the origin, one mark down is -1, and then the second mark down is -2. There's a dot there. Now the rate of change between this point and the next point on the line is given by the slope, +2 over +5. The y value will increase by 2 as the x value increases by 5. That will take us from this dot to the next dot. So start here and increase the y value by 2. 1 mark up, 2 marks up. I'm back to the origin. Now increase the x value by 5. So that's going to be 5 marks to the right. 1, 2, 3, 4, 5. There's a 5 written here on the line. There's the next dot. So I can connect these dots with a line, and we have graphed the linear equation. Now day 2, problem 2. A child is learning words. The table shows the number of words learned since the child first starts speaking. Assume the relationship between the quantities is linear. That means that assume that the pattern that you notice from row to row continues forever. Find and interpret the rate of change and the initial value. So let's first find the rate of change. How is the value of n changing as the value of t changes? From this row to this row, the value of t has increased by 3 months. From this row to this row, the value of n has increased by 120 words. If we take these two changes and write them as a rate, that's rate of change. So 120 words in 3 months. Final thing to do with any rate of change is to put it in simplest terms or reduce it. 120 divided by 3 is 40 words per month. Right. Knowing that that's the rate of change, we can work backwards in time to get from when t is 3 to when t was 0, which would be the initial value. When t is 3, the child knows 120 words. When you work backwards in time, we need to subtract away words that are learned because the child knows fewer words in the past. And if this is 3 and we want to work back until t is 0, we need to go back for 3 months. Every one of those 3 months, the child had learned 40 words, so the rate of change gets multiplied by the 3. And we just need to work this out. 3 times 40 is 120, and 120 subtract 120 is 0 words. The child initially knew 0 words.